we have incremented 2020. That is not fair. And it should be 1. So it would be smooth. So that is the goal. Okay, anyway, I have another image that we can just see. So we'll call again and Newton and Einstein. Okay. So prior to that, I think better if we print the maximum distance also, kind of. Here we are printing self distance divided by self dot max distance. You can use FR. Okay, so it would be more informative. Okay. Self distance is 20, where max distance is 404. So up to that much it would go. So we'll try now. 20, 40. 80, 100. So photograph is changing. 120, 140, 160, 160 by 404. But I think it's visible. Okay, so Einstein is visible now. We are at distance 280 out of 404. Okay, so once we reach 404, it should be completely converted. Yes. We reach the maximum and it is completely converted. We'd go back with the right click. Going back. Okay. Still it is Einstein and we are at distance of 244. Now it is more towards Newton. 164. So we are at distance 104. If we come to 0, it is all about Newton. So that is it. And then as we talked that we can make it smooth, it is not smooth. It is 20. So we can have a clock. We should iterate every second and it would save in a file. What we can do now is from Kiwi clock, import clock, and we'd start a timer. So in the constructor itself, we can start a timer here, that is clock dot schedule interval self dot update GLSL. So we'll give a function name update GLSL. Every half second we'll call this schedule clock dot schedule interval and self update GLSL and 1/2. Okay, we can comment this, we don't need this. And here instead we will have update GLSL. This is the grammar for the clock callback function update GLSL self delta, and we don't want this also right now. And we would save this. Now this would convert to 1. So touchdown, everything gone away, and we would just increment y self index. Every time it comes, it would increment it by 1, or self index equal to max self dot distance index plus 1, or self dot max distance. So it would start incrementing by 1 and it would go up to the max distance. Okay, that's it. Is the change required? Now we would save this in a file. Okay, so we can say self dot rect dot texture dot save. Now we'll save this texture into a file. I can say cat tiger plus str will have one counter, z fill with 3. Now we have a string counter and z fill 3 plus dot png. Flip equal to false. OpenGL and PNG grammar is different when y-axis comes into the picture, and we do it if self dot distance index not equal to self dot max distance, else we don't do it. Now we'll have another guy called in self dot counter equal to 0. And every time it enters, counter grows, self dot counter plus equal to 1. So initialized to 0 and then incremented by 1, and then we do rect texture save cat tiger plus a number of the image z filled by 3, so it is 3-digit number, and png filled equal to false, not equal to max distance, yes, none. So we can continue. These are the files right now. So I'll run the program. Okay, so it starts with Mr. Tiger. This is not what we want. It is doing something else. Byte must be in the range 256. Okay, self distance index plus 1, max, so it is going there only directly. It should be min. Okay, so distance, and if it reaches max distance, it would stick to max distance. That is the idea. Okay, so counter is working, timer is working, 1, 2, 3, 4. So it would do smooth transitioning from cat to tiger. It would take some time because bleating takes time. It is not that quick. So slowly it would move from cat to tiger. Now it is moving one by one. So X is moving 1. Earlier we are moving 20, 20, 20. Now it is moving 1. Okay. So now it is at distance 26. Probably we can check if files are being generated. Okay, so files are coming. That can be seen. It is at distance 49. We will watch till tiger essence starts. Okay, so it is distance 62. Tiger essence is coming. Okay, so it has reached till state 89 by 418. So certainly change is visible. Okay, it is more visible. Okay, so tiger essence is perfectly visible. So we have reached to a stage where it is hybrid image. The way we describe, like it is going in this direction and we are somewhere here at the third distance. Slowly it would proceed towards fourth image. It is proceeding. (145). So idea is that we'll have a lot of images that have a smooth transitioning, and then finally we'll club together all the images and we can create a kind of a video or GIF image that will be quite smooth. So it would take some time because there are a lot. Okay, so we are not much far. So we are at 365. Very slight ear hairs are visible of the cat. So that should go away, and it would in return it would generate the images what we want. We can browse through the images. Minkowski we have created. Now we have lot of images. Cat, tiger. Every stage we have images generated and it is being saved. You can see the transition. See this funny image. So kind of in between. Okay, so what is the status now? I think it is kind of complete. 418. Now that ear essence is kind of completely gone. Very little is there. Now it is full-fledged tiger. Okay, so we are near to done. Then we would convert it to a video and then we can see it more smoothly. Okay, so it is over. So both are at same index. So it is done. So we reached from cat to tiger. I can just close it down. And I have lot of images. I can just say FFmpeg minus frame rate some 40, 10-second image will generate. And in my I'll say cat tiger and %03d.png and output would be cat minus y cat tiger Minkowski distance.mp4. Okay, so FFmpeg is generating what we want. It is done. So we have this file now. I can see this file. Cat tiger. So I'll double. Okay, so it would bring a video. Now smooth transitioning can be seen. How it happens. Pixel by pixel.
If you are looking for Kiwi or machine learning trend, or you are looking for Kiwi and machine learning application development, or you are looking for porting your QTQML application to Kiwi, or you are looking for 3D OpenGL application development, you can contact us. You can also sponsor our videos. Please do contact.